We're going to start talking about vector data now. Vector data is one of the two key types of what are called data models in geospatial data. There are actually a couple of different types of data models. The key difference is vector and raster that I really want you to get a grasp on. In addition to that, there's some other kinds of now emergent three-dimensional models of data like LiDAR data that we'll touch on at some point in the course. What I mean by a model is it's a set of data that allows us to create a model version of the real world. And the two basic ways that we do this in geospatial data is number one, to build the model of the world with a series of points, lines, and polygons. In the raster model, we use a continuous set of pixels, which are tiny little squares that represent the world as it really is. The best way to understand this difference is to look at some examples of them. I've created a couple of things here, or collected a couple of things here for you to get a sense of this. Vectors are all built on lines and points and little areas. Rasters, on the other hand, are tiny little squares of information. And the photo of me in the upper right-hand corner here is a fairly good example of this. On the right-hand side is a raster photograph. All photographs are raster-based if they're digitally based. Things like JPEGs and bitmaps, things that you're used to seeing in the photographic world, are actually tiny little pixels of color information that make a model of what the real world looks like. Compare that, on the other hand, to a vector data model, which instead of using tiny little pixels, uses areas of color and lines of colors. As seen here in the lower left-hand corner, the raster is composed of all these little squares, whereas the vector is made up of these points, lines, and polygons. Another analogy that I really like in all of this is the difference between, on the one hand, embroidery, which is made of little, again, points, lines, and polygons of color, versus cross-stitch, which uses just little pixels, essentially, of color to represent the world in needlework art. One of the things you have to become really familiar with in vector is these points, lines, and polygons. They're going to be coming back to haunt us over and over again over the course of the entire semester. Points are X's and Y's. They're just single locations that are geolocations when we're talking about geospatial data. Lines are a series of vertices that are connected by lines. Polygons close those lines so that you have an area. That's essentially the difference and the way that all of vector modeling actually takes place. In vector modeling, there are a couple of files that you should be familiar with that, again, come up all the time. You've already used one a little bit, which is the Google Earth version, uses something called Keyhole Markup Language, or KML files. Geodatabase, or GDB, are collections of vector files. There's something called GeoJSON, which as well as a language that is essentially used to describe vectors of the world. Some of you might have used GPX files. GPX files take GPS information, again, as points and lines and polygons, and puts them together so that they can be used by GPS units. And then there's something called scalable vector graphics, which aren't particularly appropriate to the geospatial world, but that we'll probably come in contact with some point. These, again, are vector-based graphics that can be expanded in size or shrunk. They're they're scalable, as is all vector data for that matter. In geospatial data, the key vector files that we will use in this course are called shapefiles. Shapefiles are a type of file that was developed actually by Esri that produces ArcMap products. And they include points, lines, and polygons that are all included in files that also include attribute data packed in with them as well. It's really important to note that a shapefile always comes in a zipped folder with a bunch of other files in them that allow them to be used properly in a geodatabase and to be projected into a map as well. So you can't just pass a single shapefile back and forth to one another. You also have to include, in the very least, a geodatabase file as well as a projection file so that the GIS knows how to use it. So you'll be exploring all these things and using a number of them over the course of the semester.